NASA at the Kennedy Space Center in Florida is preparing to launch a Cygnus spacecraft to the International Space Station to resupply and sustain life for crews aboard the decades-old orbiting outpost. The space station continues to serve as the world's leading in-space laboratory where astronauts perform cutting-edge science and technology research to enable human and robotic exploration of destinations beyond low Earth orbit. The upcoming launch of Orbital's ATK Cygnus spacecraft will be the company's 7th mission under NASA's Commercial Resupply Services contract. Cygnus will carry 7,600 pounds of hardware and supplies, including critical materials for dozens of more than 250 science and research investigations to support work of crews on the space station. The increased cargo is made possible because of the recently enhanced Cygnus spacecraft.
It has a larger cargo module than the original standard version. We've also upgraded the avionics. We've also found ways to pack cargo more efficiently, thereby allowing us to actually launch more cargo and taking advantage of the higher lift capability.
Continuing its tradition, Orbital ATK dedicated the Cygnus spacecraft to the late Project Mercury and space shuttle astronaut John Glenn.
So the Cygnus behind me is the SS John Glenn, and to us that's extremely special. He's a hero to all of us at Orbital ATK and so many people in the space industry.
Cygnus will lift off atop a United Launch Alliance Atlas V rocket from Space Launch Complex 41 at Cape Canaveral Air Force Station. There are differences between launching to the space station and launching a payload to a higher altitude or a deep space mission.
We're going to a highly inclined low Earth orbit. Many of the missions that we fly go to geosynchronous transfer orbits or geosynchronous altitude. So we're going to be launching out of Cape Canaveral, out of Kennedy Space Center on a different inclination and to a much lower altitude to support a rendezvous with the space station.
For this mission, Cygnus will deliver several important science and research experiments to support investigations that will advance our knowledge of the medical, psychological, and biomedical challenges astronauts face during long-duration spaceflight.
We have more than 1,000 kilograms of scientific investigations on board, spanning all fields of science, you name it, physics, astronomy, biology, medical research, as well as technology demonstrations, and then of course the maintenance hardware needed to keep this laboratory up and running.
Components of NASA's newest plant growth chamber, the Advanced Plant Habitat, will be delivered aboard Cygnus. The habitat will integrate new technology to increase overall efficiency, reliability, and robustness of plant growth on the space station. The experiment will build on the success of NASA's Veggie, which was the first fresh food growth system on the station. Cygnus also will deliver a fleet of 38 CubeSats to the space station, including 28 from different universities around the world. It will be launched from the NanoRacks CubeSat deployer on the station. Among the tiny satellites is a science payload known as IceCube, which will provide data to scientists to help them understand ice clouds and their role in climate change. Genes in Space is an annual contest for students in 7th to 12th grades. Managed by the crew on the space station, this year's winning idea for Genes in Space 2 will investigate the dynamics of telomeres, the critical protective caps on the tips of chromosomes, as a way to understand the aging process. Stresses, such as those experienced by astronauts in space, could lead to irregular regulation of telomere length, which has been linked to cardiovascular disease and some cancers. Spacecraft Fire Experiment 3, or Sapphire 3, is the third flame investigation to use empty Cygnus resupply vehicles after they leave the space station and re-enter Earth's atmosphere, providing a unique environment for studying fires in microgravity. The experiment will help our understanding of how fires spread and designing flame-resistant materials to prevent fires in space. The biomolecular sequencer experiment will demonstrate for the first time that DNA sequencing is feasible in an orbiting spacecraft. A permanent DNA sequencer could identify microbes, diagnose diseases, and monitor crew member health. In the future, it also can help detect DNA-based life elsewhere in the solar system.
The astronauts are always excited to receive a new shipment of cargo and supplies. Obviously there's a lot of food specific to certain crew members. We all have our favorites, and we send them up little care packages so that they don't feel so far away from home.
Astronauts aboard the space station are performing the hard work now that will help NASA achieve its goal of helping to improve life on Earth and for missions to deep space destinations, including the journey to Mars.